Okay, this is my math lab 7.3, and I'm going to do numbers 12 through 24. So this is what it looks like if I was a student. So your numbers might be a little bit different. We're starting with number 12, which is negative cubed root of z to the 11th over 27x to the third. Okay, the first thing I want to do when I see this, the cubed root of a fraction, is change it so that it is still negative out in front, but I'm going to take the cubed root of the numerator independently, and then I'm going to take the cubed root of the denominator independently. So now I can solve each of these alone. Z to the 11th, remember, just means we have the cubed root of 11 different z's. So 1, 2, 3, 4, 5. I have 11 of them. To get, sorry, I forgot the 3. So this is a cubed root. What that means, what this 3 means, is that we want to take groups of 3, move them out. So that's equal 1z outside of the cubed root. This is equivalent to another z outside the cubed root. And here's another. And we don't have enough for more than 3. We have these 2 remaining. So that is equal to, okay, that becomes 1, 2, 3. There are 3 outside now. And then we have that same cubed root symbol, and then we have 2 z's inside. Okay, I can simplify that by saying this is z to the third, which is confusing because now I have 2 small 3's. Z to the third times the cube root of z squared. Okay, so that's how I simplify the top. Instead of z to the 11th, it is now, instead of the cubed root of z to the 11th, it is z to the third times the cubed root of z squared. The bottom, the cubed root of 27x to the third. When I have a whole number under this, I kind of want to see if it is itself a cubed root. So you can check it on your calculator by hitting math and going down here. Or you can say, what is the cubed root? Or sorry, what is 2 cubed, right? It's 8. What is 3 cubed? It's 27. So 27 is a perfect cube, we call it. 27 is the same as 3 times 3 times 3 is what that means. And then x to the third is the same as x times x times x, right? That means I have the cubed root of 3 times 3 times 3 times x times x times x. That means there's 2 things I can take out, right? I can take this out and I can take this out. So that becomes 3x. 1, 3, 1x. There's nothing under the cubed root, so the cubed root goes away. Now I'm going to rewrite this whole thing with the new information I have. So the new information is that at the top I had, not start with that. At the top I had z to the third times the cubed root of z squared. On the bottom I had 3x. And remember, I had this negative in front. So negative z cubed cubed root z squared divided by 3x. That would be the answer that I would type in for that. I'm going to pause it and write number 13 down. Sorry, it'll be choppy, but it'll save time because you won't have to watch me write things down. All right, so here we checked that 27 is not a cubed root. We can also, so this is a square root because it's an understood 2 here. So the square root of 175. Let's think about and make a list of perfect squares, okay? So 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100, right? So now those are all under 125 or 175. Is 175 a perfect square? Square root of 175 is a fraction. But I can take that 175 and I can start dividing it by these numbers. If I was to just look at these numbers, which one does it look like it might be divisible by? I can't divide it by 100, right? 175 divided by 100. 175 divided by 81. Oops. 175 divided by 64. So you can just go down the list. Sorry, you can't do that until you get to a whole number. I think I want to try 5 squared is 25, right? 175 divided by 25 is going to give me a 7. So what I can do is I can take that 175 and when I'm making the factor tree, I'm going to factor it as 25 and 7 because I know 25 is a perfect square. 25 becomes 5 times 5. 7 I can't simplify any further than that. So my factor tree is 5 times 5 times 7. And these two 5s, because they're a pair, come out. So the square root of 175 is 5 square root 7. Final answer. Okay. So what we're doing is we're just making factor trees. And we could have started with 5 and what is 175 divided by 5? 5 and 35, and then change 35 to 5 and 7. You would have gotten there, right? But you can also look at this list and say, which of these can I divide it into? Right? Okay. 14. I'm going to pause it again. Number 14 is 4 square root 80. This we're going to do just like this one. The 4 is like the minus sign. We bring it in at the end. And you can even, if you pull something out from the 80, you can multiply it by the 4. Okay, that's all that that means. These don't multiply together. But if I manage to get something out like the 5, I could multiply the 5 with a 3, for example, if it was in front. Okay? So let's look at 80. We can look at our factor tree and say, can I see anything that 80 goes into? 4, right? Can you divide 80 by 16? Oh, you can. Uh, so we can say it's 16 and 5. 16 becomes 4 and 4, and 5 remains 5. So now I have 4 times the square root of 4 times 4 times 5, because the square root, I only need 2. So these two 4s come out. And now we have this 4 times this 4 that I pulled out times the square root of 5. The 4 times 4 obviously become a 16 square root 5. So that's for number 14. All right, 15 is the square root of 150. So we could have used this list and say 150, I can divide it by 25, right? Or I can just factor it. 150 by whatever I think, right? I think I can factor it by 10, right? 150 divided by 10 is 15. 10 times 15 is 150. 10 factors to 5 and 2. 15 factors to 5 and 3, right? So that same way I found, sorry, the square root of 5 times 2 times 5 times 3. I still have these two 5s that I can pull out. So that'll be 5 times the square root of 2 times 3, or 5 times the square root of 6. Okay? If I had done it the other way, where I looked at my list of perfect squares, I would say I want to divide it by 25, because 25 is a perfect square, right? 150 divided by 25, what do I get? 6. 6 becomes 2 and 3, right? So I end up with those same numbers. I end up with 5 times the square root of 6, 2 times 3, because the two 5s came out, just like they did here. They become that. The 2 times 3 becomes the 6. So it does not matter how you start factoring it. You will still get the same numbers at the bottom. Look at 16 now. All right, the square root of 25x to the 7th. If I look at my list of perfect squares, 25 is a perfect square. So it is just 5, right? And then I have those 7 x's. 1, I have 7 x's, okay? Every pair of x's can come out. So that becomes 1x. That's 1x. That's 1x. We have a leftover because if I divide 7 by 2, I have 1 remaining, right? If I divide 7 by 2, I get 3. So that's 5 times x to the 3rd, because there are 3 of them, times the square root of x, for 16. Good? All right, this was the cubed root of 108 times y to the 11th. So I have my list of square roots. Let's look at cubed roots. 2 to the third is 8, right? 3 to the third we know is 27 from earlier. 4 to the third, it'll be 16 times 4, right? 64. 5 to the third is 125. Oh, sorry, the glare is too bad anyway. You can't see my calculator. And we're looking at the number 108. So we already went above 108. So 108 is not a perfect cube. Is 108 divisible by 64, 27, or 8? Let's check. So can you see my calculator? Weird. Like I'm using a different light. Okay. Let me pause. Sorry, it was slightly out of focus. All right. Let's look at it was 108, right? 108 divided by 64. 108 divided by 27. Good. It goes into 27. So just going to make another factor tree. 108 becomes 27 and 4. We like 27 because 27 becomes 3 when it comes out, because it means it's 3 times 3 times 3 times 2 times 2, right? The 4. You can, since the 4 is not going to turn into 3 of any kind, you can leave it as a 4 or you can leave it as 2 times 2. Does not matter, okay? So the 108 becomes 3 times 3 times 3 times 2 times 2. Because we have 3 of these, they come out, right? But the 2's stay. So that becomes 3 square root 2 times 2 is 4. Okay, so we could have left it as 4 or called it 2 times 2, but we'll multiply them back together again because they're leftovers, and we'll get a 4. The y to the 11 just means we have 11 y's, right? Another way to do it is divide 11 by 3. 11 divided by 3 is 3.6. So I know I'll have 3 whole. 1, 2, 3, and 2 left over. So if this is a cubed root, that means I have that y comes out, that y comes out, and that y comes out, but these two stay in. So that's y to the third, y squared. Sorry, there's a 3 there. Good. And now we're going to combine these two because they were together. I just find it easier to work with the numbers here and the letters here. So I'm going to say it's 3y to the third on the outside times the cubed root of 4y squared. Yeah, so if you ever see that I didn't follow this, it's just because I forgot to write the 3. So that will never change. Good? So that's 3y to the third times the third root of 4y squared. 8 is the square root of y to the 15th. Again, we can say 15 divided by 2 is 7.5, right? 7.5. So I'm going to be able to take out 7 y's and leave 1 inside. Or you have 15. You have 15 y's, you can make groups. So this becomes 1. This is 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 1. And this is 1. That y is going to stay in. So that's still the square root of y. But we have 1, 2, 3, 4, 5, 6, 7. So y to the 7th times the square root of y for 18. All right, 19 is the square root of 9, a to the 4th, b to the 3rd. 9 is a perfect square because it is 3 times 3, so that becomes 3. A to the 4th is 4a. So that means that becomes 1a, and that becomes 1a, or 4 divided by 2 is 2. And then b to the 3rd becomes 3b's. So that becomes 1b, and then we have 1b inside. So 3a squared b square root of b for 19. 20 is negative 63a to the 6th, b to the 9th. So let's look at 63 and our cubes, or sorry, our perfect squares. Can I divide it by 64? No. 63 divided by 49. Let's try it. You see my 63 divided by 49? No. 63 divided by 36? Close. 63 divided by 25? I don't think so. 63 divided by 16. 63 divided by 9 is 7. So what I want to do is take 63 and turn it into 9 times 7. 7 is a prime number. 9 becomes 3 and 3. 7 remains 7. This a to the 6 becomes, it looks like this. So that becomes a to the third, right? B to the ninth means there are 9 B's. Good. So that's 1, 2, 3, 4, 1 left over. Good. So I have negative 3 a to the third, b to the fourth, and then inside we have 7b. 21 is the square root of 9, x to the seventh, y to the fifth. 9 becomes 3 and 3. X to the seventh is 7 x's. So we have 1, 2, 3, 1 left over. Y to the fifth. 1, 2, 1 left over. So the 3's come out, 3 x's come out, 2 y's come out, and then inside we have x, y for 21. All right, this 22, the square root of 14 over the square root of 7. So in our first example today, we had 2 radicals in a fraction and we changed it to, or sorry, we had 1 radical and I changed it to 2 radicals. In this case, 14 and 7 are not divisible by any of this. 7's prime, right? And then 14 is just 2 times 7. So what I want to do is simplify the numbers 14 and 7 if possible. So to do that, I take it from 2 radical to 1. So 1 radical, and inside that radical, 14 over 7. Good? 14 divided by 7 is 2, right? Because 14 divided by 7 is 2, 7 divided by 7 is 1, 2 over 1 is 2. So the answer to the square root of 14 over the square root of 7, if we put it all under the same square root symbol, is the square root of 2. Now you might notice that this looks a lot like the other one. So we have 40, I cannot take the cube root of 40, and then I can't divide 40 by any perfect cube. And same with 5, 5 is just prime, right? So we're gonna want to do the same thing we did in 23, which is put it all under 1 cubed root. And then 40 divided by 5, if I put that in my calculator, oops, 40 divided by 5 is 8. So that is just the cubed root, don't forget this part, of 8. That's as simple as we can make it. Ooh, it is not, because the cubed root of 8 is 2. 8 is 2 times 2 times 2. Or 2 times 4. 2 is 2 and 4 is 2 times 2, if you wanted to get to it that way. You can either divide it into 3 immediately, or divide it into 2 and 4, and then divide 4 into 2 and 2. But either way, the cube root of 8 is 2. I apologize, I almost missed that. All right, 24, we have the square root of x to the 7th times y to the 5th divided by the square root of y over, or sorry, x times y. I'm going to do the same thing I did up here, put it all under 1 radical, x to the 7th, y to the 5th divided by x, y. Okay? Now, remember the rules for exponents is you can subtract, right? Or if you don't remember those rules, never fear. Let's draw them all out. There's 7 x's on top, and there are 5 y's on top. There's 1 x on the bottom, there's 1 y on the bottom. Remember, if it's common to the bottom and the top, we can cancel it out. All right, so that becomes 1, 2, 3, 4, 5, 6, x to the 6, y to the 1, 2, 3, 4. Okay, and remember, it's still under here, so I can take this and again, write it all out or divide it by 2. 6 divided by 2 is 3, 4 divided by 2 is 2. I have 6 x's and 4 y's. One, two, three. Ugh. I have trouble writing something and saying this a different thing at the same time. So x to the 6, like I said, 6 divided by 2 is 3. So that's how many x's we have. We have 3 x's. 4 divided by 2 is going to be 2. So we're going to get 2 y's out of this deal. And there'll be nothing left under the radical. So instead of the square root of x to the 6th, y to the 4th, we have x to the 3rd, y squared as our final answer for number 24.